Hey everyone, so this is going to be our very first geometry video, all right, Unit 1, Lesson 1, and it's going to be called Points, Lines, and Planes, all right? So those three things are all things that maybe you've heard of before, maybe you haven't, but it's essential that we start here, all right? Basically, all we're going to be doing today is talking about defining these words and how to label them, all right? In geometry, it's really important to know definitions, all right, to know what things are, especially later when we are going to start talking about writing proofs, all right? And it's also good to know how to label things, all right? That way you can communicate with other people and you know like what people are talking about when they write things down. So all we're going to do today is talk about some definitions, talk about labeling some things. So these three things, points, lines, and planes, all right, these are the what we call the essential terms of geometry, all right? And we're going to give them really weird math definitions over here, right? Now, what I want you guys to do, I'm not going to fill in these boxes, but over here, I want you to write your definition, all right? Because that's really how you're going to remember these terms, all right? You're not going to remember the precise mathematical definition. You're going to remember just some way that, in your own words, that you can explain these things. So you guys fill in that box to the left on your own, and then we'll both fill in this box on the right. So the first thing that we're going to talk about is a point. Now, a point is the building block of geometry. So it's kind of hard to define a point because a point is what you use to define everything else. So a point is simply a location, all right? It can be a coordinate, like on a coordinate plane, but not necessarily. A point has no size or shape. Now, we'll usually draw points as circles, but that's just our representation of what points are. Points is just a location in space, all right? And the thing about a point, so it has no size or shape. Another way of saying that is to say it has no dimension, all right? It doesn't have a length, it doesn't have a width, it doesn't have a height. So it's just a location in space somewhere. So a point now is what we're going to use to start building some other things, all right? So the next thing that we're going to talk about is a line, all right? So I hope you know what a line is, but the mathematical definition of a line is an infinite amount of connected points all right, it's an infinite amount of connected points that extends forever in both directions. So that word forever is important, all right, because in your everyday use of the word line, you're not always necessarily talking about a line, all right? Most of the time, you're talking about what we're going to call a line segment. So a line segment starts and stops. A line goes on forever. So we always draw a line with arrows signifying that it keeps going. All right, so if something goes on forever, it's a line. If it starts and stops, that's actually a line segment. So we're going to talk about that more in a little bit later. So the thing about a line is a line has one dimension, all right? So we're kind of building our way up here. A line has a length. So a point has no dimensions, all right? A line has one dimension. So a plane is the next thing that we're going to talk about. We're not an airplane, all right? A plane. So a plane is, you might have guessed it, it has two dimensions. So a plane is a flat, all right, planes are flat, a flat two-dimensional surface that extends forever, just like a line, it extends forever, and this time in all directions. So if you think about a piece of paper, right? If we were in person or on our Zoom, right? I'd be holding a piece of paper, and that it goes forever, right? That infinitely flat surface, that's like a plane, all right? So the way that we draw a plane is that a plane is gonna kind of look like this, all right? Now we can't really draw arrows on it, but you just gotta kind of imagine that rectangle, right? It's going forever. And that's the thing about a plane, all right? It's two-dimensional, so it has both a length and a width, right? But it doesn't have any height, so it doesn't go up at all. So that's why a plane is flat. So points, lines, and planes. So we could keep going up, right? If we went to 3 dimensions, right? Now we're talking about 3-dimensional shapes, cubes, spheres, pyramids, right? They have heights, but in geometry we don't really talk about 3 dimensions that much, mostly just 2. So we're gonna have points, lines, and planes, all right? So that's the definition. So the next thing that we're gonna talk about is notation, which is basically just how to write it. So the first thing, so we got this picture over here, all right? So this right here is a line, all right? And in order to name things, you have to know points on it. So just like how the definitions use the word points, right? Writing it, you need to know points, all right? Points are the most important thing. So we have 2 points on this line. We have point C and we have point D. So we're gonna use those points to name our line. So we're gonna name our line CD, all right? Every time you have a line, you're gonna use 2 letters, all right? Each letter represents a point, no more, all right? Because if you have 3 letters, that's a plane. So 2 letters, and then you're gonna put a line over top with 2 arrows, all right? It's important to have both arrows, because if you don't have the arrows, then you're not talking about a line anymore, you're talking about something else. So what could those something else's be? Well, the first is a ray. So think about a ray like a ray of sunshine, right? Is maybe how you've heard the word ray. So a ray of sunshine starts at the sun, and then it shoots out and it goes all the way to the earth, and it just keeps going forever and ever. So a ray is kind of like a line, except that it starts somewhere and then goes forever. So if we're talking about ray CD, all right, we're talking about, so we're starting here at C, and then we're going through D and extending forever. So notice there's no arrow going out on the left side, so that's why it's not a line, all right? A ray has 1 arrow. And the way that we notate that is we write CD, and then we draw a line over top with 1 arrow. So that means ray CD, and that first letter is gonna always be the letter that you start at. So we have ray CD right here, starting at C and going forever. So for a line, the order of the letters don't really matter that much, right? Line CD and line DC, they're the same. But for a ray, it does matter because you're starting. So if we're talking about ray DC, all right, that means now we're starting at D and then going in the direction of C. So think about how that might be different. So I'm gonna erase this. Now we're starting at D, all right, we're starting over here, and our arrow is going out to the left. So that's a different ray, right? It occupies a different point in space than ray CD did. So for a ray, it's important to have the starting point. And then the last one we're going to talk about is what's called a line segment. So you might have been able to use process of elimination here, but a line segment has no arrows, all right? We just have just a blank line on top. So this is what you guys mostly talk about when you talk about lines, all right? So a line segment It starts and stops. So the two letters for the line segment are where it starts and where it stops. So we have CD, so we start at C, we go to D, and we have two endpoints, no arrows, all right? So that's a line segment. So it's important to know the distinction, all right, between those three things, all right? Now we're going to talk about naming planes. So there's actually two ways, all right, to name a plane. If you look here in the bottom left-hand corner of this plane, you see an E, all right? So that's the first way to name a plane, is just using a bold, italicized letter. All right, and that would be, it would be shown in the bottom left-hand corner of the plane. So if you're creating a plane, you could just pick whatever letter you wanted, or if there was a plane already given to you, you would have to look to see what it is. So for our example, all right, we would say that this is plane E, right? That's my attempt at italicizing E. But so that'd be, we would say this is plane E, all right? Another way, so sometimes they don't give you, all right, a letter like that. So the other way to do it would be to use 3 and just write this word down, all right? You might not necessarily know what this word means, but 3 non-collinear, all right? Three non-collinear points. Okay, what does that word mean? It basically just means 3 points that aren't on a line, okay? The reason we don't want them to be on a line, so if we looked at line LMN, all right, that all 3 of those points are on the same line, so that's not necessarily giving you 2 dimensions, right? It's only giving you 1 dimension. So the 3 points that you pick need to give you 2 dimensions, right? So if we pick K, okay, now we have another direction that our lines are going off in. So we're going to pick the letters L, M, K. So we're going to say this could also be called plane L, M, K. So when you're doing a plane, you need 3 points. That way you have 2 dimensions to your plane. All right. So that's how you would name a plane. The last thing that we're going to talk about is we're actually going to define this word up here. So not exactly that word, but we're actually going to define the word collinear. So you guys know what linear means, all right, from Algebra 1. Linear means it makes a line, right? A linear function makes a line when you graph it. So co means like together, right? The prefix co. So collinear means together to make a line. So points are collinear if they lie on the same line. So another way to say that is points are collinear if you can draw a line that goes through all of those points. So if we look up here, all right, L, M, and N are what we say they're collinear. All right, they all lie on the same line, but L, M, and K are not collinear because K is off the line. So you need at least 3 points to be collinear, but you could have 3 or more points. And so another similar word is coplanar. So hopefully you can guess what that means. Coplanar is this time 4 or more points that all lie, actually not 4. Yeah, 4 or more points that all lie on the same plane. So if we look up here, right, L, M, N, and K are all coplanar. because they all lie on the same plane. It's hard to think about a point that's not in that plane, because if I draw that point right here, well, this extends forever, right? So it would get this point. You kind of have to think about taking this 2D plane and turning it 3D. So if you think about, right, this is above the plane, right? Like if this is a height, if this is a height dimension right here, this point, let's say point H, right? It would be above the plane. So the plane is extending, it's extending flat, right? But it's not going up. So H would not be coplanar with L, M, N, and K. So hopefully this made sense. This is our first time trying this out. So if you have any questions on any of this stuff, ask them in the beginning of the Zoom meeting, all right, Zoom class period. I'm more than happy to go over anything that you guys were a little bit confused about here. And then during class, all right, we're going to answer these problems. So don't worry about answering these problems now. That's what we're going to do during our Zoom meeting. So again, if you have any questions, make sure you have them ready for the Zoom meeting. And other than that, have a great